Lakshmanan. I'm senior lead engineer in IBM ISL. I have been using Elasticsearch for past 8 years from 2.3.2. I tend to enjoy exploring new tools and technologies. That's how I bumped into universal profiling and I started exploring that one. So let's see the agenda. Okay. The first thing is we will see the common performance issues that we are getting. Okay. So the common performance problems that we are incurring in the cloud or the customer environment or production environment. Then we will see how the traditional monitoring of these performance issues or fall short for us. Then we will go into the solution which is needed for the modern approach, like the current approach. Then I'll introduce eBPF, how universal profiling is leveraging eBPF and its advantage. Then we will dig deep into universal profiling, like setting up and how you can install and how you can make use of it. Then last but not least, they have open source the agent thing. So we will see how you can make use of that agent. Okay. So coming to that problems. So I think almost all of us will be wondering that some of the issues are some issues like specific issues like that will only happen in the customer place or the production environment, and that will not ever happen in our development environment or testing environment. So I have just listing some of the issues here. So first one, we tend to go with slow startup, right? So application used to start very quick in our environment, but it always or sometimes starting up very slow in customer environment, and if we are hosting it as SaaS, it's our problem, right? So in production it might start slow. So it will be very difficult for us to identify that issue, right? So it needs to happen in our environment so that the developers can check that one. So the next one, bottleneck. The applications generally will work fast, right? So generally the thing is it will suddenly start to slow down. So that's the reason, and that too it will happen sporadically. So it will be very difficult for us to set those environment here and reproduce that, and we have to get to the root cause. So that is another issue. The thing is sporadic performance drop. So that is nothing but related to bottleneck. It's like working perfectly fine, suddenly the performance drops, we don't know why, and especially it might happen during the high traffic or it might be in the customer environment. So we will not be able to reproduce that locally and everything. The another thing is auto scale. So it's like we tend to do the auto scale because we want to make sure that our application is highly available for the customer. But the problem is sometimes it will take more time, and sometimes it will not be able to scale due to some issues. So all these things will happen. So these are the things that generally we encounter, and other than that we will be encountering like network issues and latencies and everything. I have just listed some of the 4 here. Okay. So what do we do generally when we encounter these issues, right? So we generally go with the first thing called profiling tool to get more insights on the profiling tool. But the problem is, even though we have the profiling tool, it is very difficult for us to set this thing up, right? So if it is done wrong, right, so it will not give you the accurate data, and you will miss the chance to optimize your code. Then each profiling tool will be having a special configuration that is tailored to your application. So when you do these kind of these things, right, your application implementation might get complex, and any configuration, if you do any small mistake in the configuration, then you will get inaccurate data, inaccurate metrics, and it will lead you to misguided configurations or misguided optimizations, right? The next thing, sidecars. So sidecars are generally useful when you are trying to offload the monitoring or the profiling to the other node, so that your application node is not getting overwhelmed, right? So but the problem with this is it is increasing your footprint in the resource, and troubleshooting the steps whenever the sidecar is having issue, it's very difficult. The next thing, sporadicity of the issues that we have spoken earlier, right? So it's like it's like we have regular tests to identify that, but we will not be able to do that, and the issues happen sporadically, and it will be very difficult for us to identify the pattern and monitor that particular use case or a state to identify the issues. So those things are another set of problems when we encounter these kind of performance issues. When we talk about the profiling tool, right? So they mostly depend on instrumenting our code and adding additional information like debug symbols to our code. So basically, this will add a lot of overhead to the applications, and it will certainly cause performance drop in our application. So that is the another issue. So when we combine all of this, the other thing is cloud deployment. So we have all these things. So we have hosted our application in the SaaS. Now if we want to do anything, it will be very difficult for us to do the profiling in the cloud, because we need to either re-image that with the specific configuration or the profiling tool, or we need to get the help from the DevOps or the cloud ops to deploy the specific image to the prod, so that we will be able to profile the data. And that too, the problem is we don't know whether we will be able to get the exact data, or whether the issue will happen if it is sporadic. So all these things will happen, and we will not be able to do that all the time. We have to have a specific set of window. In fact, if needed, we need to get the permission from the customer to do that one. With these difficulties, it is very difficult for us to deploy all these things in the cloud, right? So the next thing is, even though if you get everything, you have to go through all the details, logs or the stack traces, whatever you are getting, right? You have to go through with manual effort. So always manual efforts are prone to human error. So that is one more difficult thing that we are in the performance monitoring. So the next thing, each language is having lot of profiling tools with respect to its own thing, and it is very difficult for us to go through all the profiling tools for a single set of language or single language. So that is the problem. And even though if we set this one, the monetization model or the configuration or the learning curve related to each of these profiling tools will make you think that even if you master any one of the tool, if you want to set up the tool for another language, you have to start it from the scratch. So that's the problem with the profiling tools. This is where I think I missed this slide. So this is where we come to know that we need a proper solution or the modern solution to address all these things. What the first thing is, we need a unified tool to collect all the data across all your fleet. It's not like that I'll use this tool for this particular set of architecture or environment, or I'll use this set of tools for this environment. It's not feasible for us. So we need a unified tool. Another thing, we need a single tool to collect the profiling data for all the process or all the languages, or I would say that application agnostic tool to collect the profiling data. The next thing, how it integrates with the existing application or the environment, right? So it should not require any extra configuration or resources to deploy that one, or special learning curve to deploy that one. The last thing is continuous profiling. So this is the most important one in my opinion, because the most of the issues that we encounter are mostly sporadic or bottleneck, right? So to solve these things, we need to profile the application continuously for longer period of time, so that we will be able to identify the pattern or the issues that are actually occurring. And in fact, it will help you to solve the problem even before the customer reports that one, if you come to do the profiling continuously. So that's why that's where the universal profiling is coming. So it is a tool provided by Elasticsearch. It is able to collect the profiling data with less overhead, and it is able to do that using by leveraging eBPF. And I'll go to this thing. So what is eBPF? How it is being used? We will check that. So eBPF is a tool, okay, that is used to execute the user code in the kernel space. So generally, what we will do if we are facing any issues, right? So we will be writing code, but we will not be having any privilege to run that in the kernel space. In fact, so it will enable you to run your application in kernel space to collect the performance metrics, or you can do anything. So it literally allow you to hook anything in, hook to the kernel probes or user probe or any perf events, trace points. You can hook into anything and you will be able to collect all these metrics. It will help you to do that one. So why eBPF? So the first thing, I'll start by giving one example. So in 2017, there was an issue with the kernel, right? So DNS lookup sporadically takes 5 seconds. Okay. So the issue was reported in 2017, and it was actually been logged, and the issue analyzed in March 2018, and the actual patch was submitted in August 2018, but it got approved in the kernel community by 2019. So basically the problem is you have identified an issue, okay, but the problem is you need to get the permission from the kernel community to get it approved and available in the kernel. And if you consider the period, right, it took around 2 years for the patch to be available in the kernel. It will take another 1 year so that the OS that you are using, right, to be built on top of that kernel. So it might take another 2 to 3 years, right? So that's where eBPF helps you to do that one. So once you have identified any issues, you don't need any kernel level thing. So you just need to write the eBPF code, and you can do that in any of your favorite language like Go, C, Python, and recently Java has started to support eBPF. You can do that and you can start executing the eBPF. The second thing, safety. So when we allow everyone to modify or hook into kernel, so what about the safety, right? So eBPF is providing eBPF verifier, where it will actually checks about memory leaks and control flow statements, data type integration, and something like how it is behaving. So all these checks has been done by eBPF, and it provides you the safety that it will not crash the kernel. Even if there is any issue with the eBPF code, it will silently exit and it will not do any problem to the kernel. The next thing, efficiency. So eBPF provides a JIT compiler. Okay, what it will do, the bytecode that is compiled in the user space will be converted to the native language using the JIT compiler, and because of this, it is actually avoiding the overhead, application overhead. So, and another thing, since it is converted into the native language of the machine that it is being deployed, it is able to avoid that communication between the user space and the kernel space for getting some other information. Because of this, it is able to avoid overhead, and it is being able to perform very fast. The last thing is accessibility. As I mentioned earlier, eBPF is now available for almost all languages like Go, Python, C, and in fact recently Java. So all these things you can write eBPF code and you will be able to deploy it into your machine, and you can start getting all the metrics that whatever you want. So how eBPF is leveraged by universal profiling to collect the data. So first thing, you need to have an Elasticsearch account. In that, you need to configure the universal profiling. A collector will be hosted in the cloud, where all the metrics data will be collected. Then there will be visualization separately available. You can go and you can see all the data. We will go to that later. So before that, you can consider a single node where it is hosting multiple containers or pods. Okay, and there is a kernel space. From kernel 4.2 onwards, eBPF subsystem is available with kernel. So you can take any latest OS and you will be able to execute eBPF code. The main part here is the universal profiling agent, which is the binary that will be deployed in your machine. Okay, you can deploy it in your machine and you can start collecting performance metrics or the metrics that whatever you require, right? So from across all the pods and all the process that is running in that machine. So to note that one, so that profiling agent is installed on the node, not per application or not per pod, and it is able to collect metrics and profiling data of all the 4 pods, and it doesn't know what the application is hosted inside the pod, and it is able to collect the process that is running in the node itself. Okay, so how it is doing? It is having some eBPF bytecode. Okay, that will be pushed to the eBPF subsystem, eBPF verifier first. So the eBPF verifier first verify all these things like memory checks, control flow statements, and safety, any other safety checks, all these checks they have, just to avoid, so that your code does not intentionally crash the kernel. So it will be pushed to the eBPF verifier. The next thing, that bytecode will be given to the eBPF JIT, so that it can be converted to the native language or native code, right, specific to the architecture that you are running. So it will be converted to the optimized bytecode by doing dead code elimination and improving the control flow statement and other things. It will do some more optimization to the bytecode. In fact, it will try to use the CPU cache, register and everything. So once that is done, the data structure called eBPF maps, that is being used by the user space and kernel space to communicate. So whatever the data that you want to give it to user space, you will be using the eBPF maps. So the eBPF subsystem will execute the optimized bytecode, and it will get all the metrics, push it to eBPF maps, and from there you will be able to get that metrics to the corresponding agent that is running in the user agent, right? So once that is done, all these metrics are being pushed to the collector that is running in the cloud using a format that is currently in the water format, that is in experimental state, the open source form. So it will be pushed to the collector. Once that is done, you will be able to visualize all the metrics. So
the universal profile it is written in C, it is besides user space or what?
sorry.
Hello. Can we take a question later? Yeah. Thank you.
Okay. So we'll walk through about the setup, visualization, and what are the insights that you can get from these metrics and visualization. Okay. The first step would be the setup. It will be pretty much straightforward. Go to the cloud account, go to the universal profiling link, and there will be this windows. Just click setup universal profiling. So in that account, if the universal profiling is not set up earlier, you will be able to, it will be able to set up the collector and other related things to collect the metrics. The next step, they are provided lot of flavor of deployment, Kubernetes, Docker, binary, packages, and how you want to integrate. So all these things are available. And for this purpose, I just took a screenshot of the binary which I used. The thing is, you just need to download the agent, give some executable permission, and run it with the token that you will be able to access your cloud account. That's it. Once you done with that step, it will be able to collect all the metrics. After some time, you will be able to see all the stack traces in the visualization. For this demo purpose, I have created a small CPU spike simulator where it will be trying to check whether a number is prime or not by running the loop, so that it will be able to spike the CPU. And I have done that with Java, Go, and Python, just for the demo sake. I have hosted that in one of the container in one of my Linux machine. So the first thing, this in the visualization, we need a proper visualization tool to see that one. So the main thing that is used by the universal profiling is called flame graph. That is generally used to see the profiling details. That is a famous one for seeing the performance thing. This is the entire flame graph. In this, I took the part of this one where it is explaining what is the Java stack trace that is causing the CPU spike. And in this, if you see the lines, right? So if the Java class are built with debug symbols and other thing, it will be able to collect the class name and in fact the function name till line number. It will be able to collect all these things using the perf event, and it will be able to push it to the Elasticsearch, and you will be able to see the entire stack trace here. The sample code that I used to simulate, right, that exactly matches with the stack trace that is being deployed there. And the next thing, this is the entire flame graph of the duration 15 minutes, where all of my actually code, right, Go, Python, and Java is trying to spike the CPU. And you can see that what is the percentage that each of these is being used, and in fact the depth of the stack trace, right, whatever that is being collected is available. For Go, since I didn't build it with debug symbol, you will be able to just see the binary name. And with respect to Python, you will be able to see, like Java, you will be able to get the class name, function, and in fact the line number that it is getting that one. It's nothing but the sample Go code that I used. So if we build it with debug symbol and other thing, it will be able to show which line is causing the issue and other thing. So basically this means, I'll go. Basically this means any language, universal profiling will be able to collect the information. The next thing, it is providing a lot of insights like what are the top n functions that are causing the issues. Once you identify that one, which container it is causing the issue, you will be able to see that. So container is what are the process that is causing the issues. The next thing, generally we will be having the container that are running in multiple nodes, right? On which node you are getting the issue. In this case, I'm using the single machine, so all the 100% of the issues are coming from that machine. So everything is being reported from that machine. And the last thing, the open source eBPF profiler, they have open source this April. Okay, so the agent is available as an open source hotel eBPF profiler. If you want, you can just download that, build it, and you will be able to push the metrics to any open source collector. So that is all. The protos are in experimental state. You will be able to use that one still using gRPC and HTTP. And once you understand the protos, you will be able to build the custom application or custom solution on top of this one, like rising alerts and any other thing. So this is the next. This is just a sample of that metrics that we are collecting in the from the pods using the proto. So any question? And these are the topics I would like you to go through if you are interested, like the profiler, proto, and universal profiling, all these things. Any question? And
Yeah, that agent is in the user space, right? That universal profiler agent.
agent is built by Elasticsearch itself.
But it resides on the user space or in the kernel?
It resides on the user space. The eBPF bytecode will be pushed to the kernel space once you
So
start the application.
Agent automatically compiles.
Yes, the eBPF subsystem is available as part of the kernel, so it will be able to execute. So currently,
it takes the bytecode in the C, then that user agent is like which language?
it can be any language. So
No, it inspects any language, but that user agent is in.
you can write it in Go or Python or C. The user agent itself. It will contain some bytecode of the eBPF that will be in C. Okay, that particular language library you are using, right? It will know how to push that bytecode to the eBPF subsystem. So once that is pushed, it will be able to collect all the data by hooking it to the corresponding events.
And specific OS, because when you showed right one, it gives you a pop-up saying that some kernel host OS Fedora, that pop-up was there. Any specific OS kernel 4.2 or any other?
That was actually a message from universal profiling. They are having some issues with some specific kernel. You need to patch it. They have the steps, but it is available from 4.2.
Yeah, that.
Is it recommended to run during production, or like is there any overhead?
You can run this for the production continuously. Okay. The overhead claimed by universal profiling is 256 MB of memory overhead and 1% of CPU overhead.
Okay, thank you.
Anyone else? Yeah.
Hi, thanks for the talk. Just one question, like does eBPF also help you to let application logs, or if I have any custom metrics in my code?
I think it will not directly allow you to or help you to collect application log, but it will helps you to collect the metrics that are available in the kernel space by hooking.
But if I have a custom metric like a particular counter of some errors in my application that I'm tracking,
if you are able to extract that from the kernel space, right? So any hooks you can
anything
use,
that I can extract from kernel. That's
yes.
Okay. Cool. Thank you.
So just you're talking about the metrics only, or logs, or any data? So we got a OTel distribution. We having our own OTel distribution, which is nothing but the open telemetry capability plus elastic capability we have. And it's open source. So in that you can relate universal profiling metrics, the kernel space, with your APM data. So you can actually connect the resource. If this API is taking time, which function, which kernel space, and you can literally drill down to it. Yeah. Thank you. Yeah. Any question, folks? Yeah.
So can we set up eBPF with managed instance, or like is it a premium feature in Elastic Cloud?
No, that's what. So if you are able to install, you can directly get it from here. Or else, what you can do, you can extract, fork the open source, and you can build the agent by yourself, and you can deploy it into any of your managed instance or anywhere actually.
Okay. Yeah. Thank you.